So last week we worked on testing if ordered pairs were solutions to our inequalities. And we did that by replacing x and y. So we're going to do that same thing today. So if I wanted to check if the ordered pair 10, 3 was a solution to this, I would replace x with 10 and y with 3. And I would see if that was less than 6. So I get 10 minus 9 is less than 6. 1 is less than 6. That is true. So yes, it would be a solution. So I could do that for each of these. So I could replace y with 2, x with negative, and I would get negative 2 plus 5. 2 is greater than 3. That's not true. So I could do that here, but I'm going to pause on that. So one thing I want to point out is that the difference between, if I have an equation, I just get a line. That's it. If I change that to an inequality, I'm going to get a line. I'm also going to get a shaded region, and if it's a certain type of inequality, I'm going to get a solid line or I'm going to get a dotted line. So if I'm going to get greater than or equal to or even less than or equal to, then I'm going to get a solid line. If I get less than or greater than, I'm going to get a dotted line. And so what that means is that here, if I want to pick a point that's a solution, it can come from the shaded region, and in this case it can also come from the line, and in this case it cannot come from the line. So that'll be important when we get to the next part. So in order to graph these, we're going to do, first we're going to just graph like normal. That'll be easy. Then we're going to choose what type of line we should put, like we just talked about, solid or dotted. That's pretty easy. It's going to be a solid line if it's greater than or equal to or less than or equal to. It's going to be a dotted line if it's greater or less. And if you think about it, like solid line means it can equal that thing, so we want to like include it, and then here it's saying it can't equal it, so we're going to exclude it. And then the newest part is going to be this test point. So for example 1, I'm going to start by graphing it as y equals mx plus b. I'm going to treat it in my mind like an equation. That's why we just graphed all those lines. So that means I'm going to begin at the negative 3, and then I'm going to rise and run up 4 over 1. And then because it's greater than, if I look up here, it's going to be a dotted line. So I'm just going to graph that with a dotted line. It's going to go like this. So now I want to decide, should I color this side or should I color this side? And to do that, I'm going to pick a test point. The easiest test point to pick is the origin, because zeros are really easy to work with. So that means I'm going to replace x and y with 0. So 0 is greater than 4 times 0 minus 3, which is going to get me 0 is greater than, well, 4 times 0 is 0, and 0 minus 3 is negative 3. So that says that 0 is greater than negative 3. Well, that's not true. So that means the origin is not part of the solutions. So that means the solutions are over here. So I'm going to color in this side. That's it. So if I do the next one, we're just going to do all of these together just to be way easier. So I'm going to begin at 1. That's my y-intercept. My slope is 3. So I'm going to rise 3, run 1. 1, 2, 3, 1. Do it in both directions. Down 3, left 1. Down 3, left 1. And again, my inequality is greater than. So the line. And then I'm going to test 0, 0. Technically, that doesn't look good, but it's not on the line, I promise. The line's like over here. So I'm going to do 0 is greater than 3 times 0 plus 1. 0 is greater than 1. That is not true. So I'm going to shade the opposite side of the origin, which is over here. So if I wanted to find on both of these points that are solutions, I'm not allowed to pick points on the line, but I am allowed to pick points in the shaded region. So like in this case, like 4 would be awesome. Or here it would be like negative 2, positive 4 would be fine. All right, then down here, this time because y is not isolated, I'm going to graph it as if it were x and y intercepts. So I'm going to change x to 0, or sorry, y to 0. I'm going to get x equals negative 1. And then I'm going to change y to x to 0. I'm going to get y equals negative 1. And this time it's greater than or equal to, so I'm going to connect it with a solid line. And if I were to replace the origin, 0 plus 0 is greater than or equal to negative 1, 0 is greater than or equal to negative 1, that's true. So the origin works this time, and this time the points on the line also work. And then same thing here, because y is not isolated, I'm going to do x plus 3y equals negative 6. If I change y to 0, I'm going to get x equals negative 6, so that's here. And if I change x to 0, I'm going to get 3y equals negative 6, so y will equal negative 2. And then before I connect, I look at my inequality and say, okay, that's less than, so I want to make sure I connect them with a dashed line. I'm going to test my test point of the origin. 0 plus 3 times 0 is less than 6. Or sorry, less than negative 6. 0 is less than negative 6. That is not true, which means the origin's not a solution, so I'm going to shade the other side. So the shaded region is representing what is a solution to the inequality, and then the line itself is only a solution if the line is solid, and the line's only going to be solid if it's greater than or equal to or less than or equal to. If the line is dotted like this, that means it was not, it's just separating the shaded region from the non-shaded region.